Guys, welcome back to Solving Systems by Substitution, day 2. So today's going to be mostly a review lesson. Just a few quick reminders here at the beginning. If you have questions, make sure you're emailing me right away at bmcneely@heronhighschool.org, and then make sure you check back your email that day or pretty quickly. If you're waiting a week to check your email again, then you're not seeing my response. It's definitely not too late to turn in late work. Go back to the beginning of the e-learning and do whatever it is that you haven't done. If you need your PowerSchool login to figure out your missing work, just let me know. Set yourself up for success. Make sure you have out your pencil and paper. If you don't, then you need to go get some now. Make sure you're logged into your school email address. The Google Forms IP will be locked unless you are logged in with your school email. When you email me and tell me that you can't get into the IP, I know you are not listening or watching the videos. There's never a reason to guess, leave blanks, or write IDK in an answer blank. Make sure you email me or attend office hours to get your questions answered. Don't forget about remediation at the end of the semester. To be eligible for remediation, you have to have a 60%. I know the transition to e-learning has been difficult, but most of you just have an NG because you haven't been doing the e-learning. As soon as you start submitting assignments, that grade will go right up. Thank you to everyone who's putting in the time to watch the videos. You should be watching, if there's 2 videos, you need to make sure you watch both. Don't forget to listen to the code word for today. All right, let's do a quick review on our email etiquette. We've talked about, first of all, the difference between the subject and the body of an email. The subject should be just a one sentence, less than one sentence information about what the email is about, and then what you're writing should go in the body of your email. So for example, in my email to Miss Dorsey here, my subject is hello. My body says, hello, hope you are well. I wanted to ask if I could miss the advisory meeting today so that I could attend an online meeting about the new SAT requirements. Please get back to me ASAP. Take a second and think about what's wrong with this email. What should I change? What I should change is get back to me ASAP should never be used in an email. I would not write this to Miss Dorsey. I would not write this to Mr. Harper. I would never say, please get back to me ASAP. So let's fix this. What I could say instead is something like looking forward to hearing from you. And then notice I've already got my signature at the bottom. You always want to close by putting your first and last name, especially when you start emailing your professors in college. They're going to have more than one student with your first name and sometimes more than one student with your last name. So you might want to make sure you're putting first and last name beside your emails. Don't forget, you can get some bonus points by sending me a polite email this week. It must be from your school email. Have an appropriate subject, a polite closing and greeting, and have mostly correct grammar and punctuation. Really looking forward to hearing from you. Shout out to Alejandra, who already got hers out yesterday. Nice job, Alejandra. All right, let's do some quick review here. If I asked you to solve the proportion, every proportion can be solved the exact same way using what we call cross multiplying. We multiply across diagonally. If you remember to put any expressions in parentheses, that makes this much easier. You can do -2 times 2x minus 5 equals 4 times 3x minus 7. Now we can see that we need to distribute to get rid of our parentheses. -2 times +2 is -4. -2 times -5 is +10. Bring down the equal sign. 4 times 3x is 12x. 4 times -7 is -28. Now we can see that we've got variables on each side. We want to get the like terms together. So I'm going to add a 4x. Since that's a -4, I'm going to add a 4x to get our like terms together. Bring down the 10. We add the coefficients. 12 plus 4 is 16x. Bring down the -28. Now we have 2 constants that are on opposite sides. Again, we want to get the like terms together. So we're going to add 28 to each side. So we get 38 equals 16x. And then we want to separate the 16 from the x so that we can isolate x. And so what we end up with is this weird thing that looks like 38 over 16. If you have your calculator, you can reduce pretty easily. If you don't, you should think about that these are both even numbers, so they can be divided by 2. And so this turns into 19 over 8. It is perfectly okay to leave it improper. There's no reason to change that to a mixed number. All right, see if you could pause the video and try this one on your own. Welcome back. You should have noticed that we had some like terms on the same side. I should not be subtracting 3w from 4w. This 3w and 4w are on the same side, so that's treated like an expression where we combine like terms. 3w plus 4w is 7w. We bring down the plus 5. On this side, we can see that we want to get rid of our parentheses, so 4 times w is 4w, and 4 times negative 2 is negative 8. Now we've got like terms on opposite sides, so we're going to do the opposite. The opposite of a positive 4 is a negative 4, so we're going to subtract 4w from each side. That leaves us with 3w plus 5 equals negative 8. Now we want to get our like terms together. 3w doesn't match with anything else, but the 5 and the negative 8 are both constants. We're going to subtract 5 from each side. We get 3w equals negative 13. Divide both sides by 3 to isolate the w, and so w equals negative 13 over 3. That can't be reduced, and there's no reason to change that to a mixed number, so we just leave it there. All right, last time we talked about solving by substitution. We talked about the fact that when I have an equation that has two variables, I can't solve it because I don't have enough information. If I have two equations, though, with two variables, I can use those to substitute into one another to drop it down to one variable. So that's the goal. What I'm looking for is a variable that's already isolated. I notice that the y's are already isolated, and I know that y in the first equation is equal to 6x minus 10. What I'm doing is replacing the y with the 6x minus 10 because I know they're the same. These two y's are the same. If this y is equal to 6x minus 10, then this y is equal to 6x minus 10. Remember, we talked last time about what I'm doing is taking away your dollar, but I'm replacing it with 4 quarters. It looks a little larger and different, but it's the same amount of money. Now this is what we were working on a while ago. I have an equation that has like terms on opposite sides, so I want to get those x's together. That's a positive 6x, so I'm going to move it by subtracting 6x from each side. So I get negative 10 equals 2x minus 14. Now this is just a two-step equation. I have constants, which are like terms on opposite sides, so I add 14 to each side. So we get 4 equals 2x. Divide both sides by 2, so x is 2. Now we're half done. What we have is the x value, but we also need the y value. Remember we talked last time about I can use either one of these equations. It doesn't matter which one. For just this time, I'm going to use both so that you can see that that's true. Sorry, that should be a minus. If x is 2, then for the top equation, 6 times 2 minus 10 becomes 12 minus 10, which is 2. If I use the bottom equation, it's 8 times 2 minus 14. 8 times 2 is 16. 16 minus 40 is also 2. And then we're supposed to write this as a coordinate point. We found that the x value was positive 2 and the y value was positive 2. All right, leave this on your screen, pause the video, and try this next problem all on your own. Notice that x is already isolated, so you should be substituting for x. Welcome back. You should have noticed that x is equal to 3y plus 3, so you can replace this x with 3y plus 3. So this becomes 3y plus 3 equals 15y minus 45. You should have noticed then that you have a multi-step equation with like terms on opposite sides. I am going to get my y's together on the same side, so we're going to subtract 3y from each side. So we get 3 equals 12y minus 45. I want to get my constants together on the same side, so I'm going to add 45 to each side. So 48 equals 12y. I'm going to divide both sides by 12, and so y is equal to 4. I'm half done. I now know that part of my answer is a 4. The y value is 4, and so I can choose either equation. I'm a lazy mathematician, so I'm going to use that top one because the numbers are smaller. If y is 4, then x is 3 times y plus 3. 3 times 4 is 12. 12 plus 3 is 15, and so x becomes 15. You could have used the other equation, but I didn't because I'm a lazy mathematician. Those numbers are too big for me to mess with, so I used the top equation. Nice job. All right, you won't have to draw a graph on your Google form, but there will be questions about how to solve a system by graphing. I want you to solve the system using a graph. So let's see here. This one doesn't work because we don't have another equation. So actually, instead, what we're going to do is just use this to review our graphing skills. I noticed that this equation is in slope-intercept form. So I need to start with the beginning. The b stands for my y-intercept, which is the constant. which means my starting point there is 2. My slope is 3/4, and so I'm going to go up 3 and to the right 4. Because remember, slope is rise over run, so that's telling me to go up 3 and to the right 4. The top number is always how much you go up or down. The bottom is how much you go left or right. And so now I'm going to connect those with a line, and that's it. We can't solve the system because we don't have a second line, so these directions don't make any sense. So let's go on to the next screen. Identify the equation that has one variable isolated. Okay, so I want you to look at these equations here. And I want you to notice that, unlike what we were doing on the previous problems, this equation does not have both variables isolated. So we want to first, and I would write this in your notes, identify the equation that has one variable isolated. There it is, right there. So step 1 is noticing that y is isolated and it's equal to 2x plus 14. Step 2 is substitute that expression into the other equation for the isolated variable. So we take what we got for y, which is exactly how we started previously. Now we go to the other equation, because this is a system, they have to work together. And I'm replacing y with 2x plus 14. If you will replace what's in the box with parentheses, this becomes much easier. Because then you can see that what I actually have to do is distribute. I've got the 3 next to the y, nothing else has changed. The 2x is still there, the 3 is still there, the equals 18 is still there. I've just replaced y with 2x plus 14. Now I distribute. Let's see, I don't know what 3 times 14 is off the top of my head, so I get out my calculator. And I get 42 for that. I add my like terms that are on the same side, so that's 8x plus 42 equals 18. I'm going to rewrite this so that I have some room to write. I'm going to subtract 42 from each side. So 8x equals 18 minus 42, which is negative 24. We're going to divide both sides by 8. The 8's cancel out, and so x equals negative 3. Now remember, that means we're only half done. We have the x value. What we need is the y value. Now, you can use either equation, but this one we started with y isolated is going to be much easier to use. I already know that x is negative 3, so I replace x with negative 3. Remember, I'm replacing that in parentheses. 2 times negative 3 becomes negative 6. Negative 6 plus 14 is equal to 8. So my solution there is negative 3 comma 8. If you have not written these steps down along with this example, I would go ahead and do that now. All right, let's go ahead and pause the video here and we'll pick back up on the next video. So go back to Haiku and let's go to video part 2 for today.